two blocks, a pulley, and an incline. We always begin by drawing the vector diagram. The mg acts down. The components are drawn as follows. You've done that before. Theta is as shown, and that component is mg sine theta, and this one is mg cos theta. If necessary, hit pause and look at it. The force acting down the incline is mg sine theta. That's how much of the weight acts down. I'm going to call it F sub d, the force down the incline. Little mass m has a weight, little mg, acting down, and there's tension in each of those in the string, and the tension is the same throughout the string at every point. So, what is the equation for F net equals ma for the big system? And we would use that to find acceleration. And first we need to try to find out which is the bigger force, Fd or mg. Now, if you pick mg, for example, and turned out it was wrong, and you solved all of the equation, and you ended up with a negative acceleration, all it tells you is that you selected wrong, and you know it actually goes the other way. We'll suggest that Fd is the larger one, and it's going down the incline, and we'll treat this situation as such. So we need to find the net force, which will be Fd, that's acting down the incline, minus little mg. Those are the only two forces acting on the total mass system. And so Fd minus mg equals the total mass, which is big M plus little m times A. But we notice Fd, we know what that is, and Fd is mg sine theta. So there's the equation, the F net equals ma for the big picture of the two blocks and no friction. Now let's get two more equations by looking at each block in turn. We'll isolate large mass m. Now we need an F net equals ma equation for this. Well, the larger force is Fd, and we subtract the smaller opposing force on that individual block, T. So the net force is Fd minus T equals ma. Now we isolate the smaller block, and let's look and find an F net equals ma equation for that situation. Well, the larger force is T. It's accelerating upwards, we've decided. And so the net force will be, look here, T minus the smaller opposing force, mg. T minus mg equals ma.